Okay, so let's speak about regular expressions. Um, so regular expressions are essentially a shorthand to specify regular languages, similar in nature to what we already seen. So another way of thinking about it is that we specify a pattern, and the language is going to be all the strings that match this pattern. Now, regular expressions are widely used. They're used in text search, in editors, in things like grep, Emacs, etc. And they're also used in compilers for lexical analysis. Essentially, the first stage of a compiler execution is that it reads in the program, which is a text file, and it breaks it into tokens, where every token is specified using regular expressions. And it's a very compact way to write down interesting patterns that in a useful way. That dates back to the 50s to work by Stephen Kleene, which is the guy that the Kleene star is named after. Okay, so a regular expression, we will usually use small letter to write regular expression to distinct them from the language itself, which we will use capital letter to write. So the definition is recursive, and it's similar to what we said before. The base cases is that the empty sets denote the uh, empty language, right? The language with no strings. Epsilon denotes the language that contains one string, which is the empty string. And a single character denotes the language which corresponds to a language that contains one word, which is this character. Um, and now we have the induction, right? So in the induction, we have two expressions, R1 and R2. When we write R1 plus R2, what we really say is take the corresponding languages and take their union. If you want to think about it as a pattern, which is the more natural thing, this means given a word, it matches this pattern if it matches R1 or it matches R2, or of course both. Similarly, R1 dot R2, which usually, by the way, we will write without the dot. We will just write R1, R2. This corresponds to concatenating a string that matches R1 with the string that matches R2, right? So as far as languages, just correspond to taking the languages of the two regular expressions and concatenating them. If you want to think about the pattern, this pattern match a word. If a word can be broken into two parts, such that the first part matches R1 and the second part matches R2. And the third construction operator is the Kleene star, which is R1 star, which corresponds to taking the corresponding language and applying the R star to it. As far as pattern matching, this pattern matches a word if it can be broken into a sequence of words that are all concatenated together, so that each one of the words in this breakup corresponds to matches R1. Okay, so here's the equivalent way of defining regular languages and regular expression. As you can see, it's very similar. Regular languages are somewhat less convenient to write down regular expressions, so that's nice. But at some level, when you write a regular expression, what you really mean is the corresponding regular language, right? And um, and when it's important, we will explicitly write it, right? So if we have a regular expression R, we will write L of R when we really refer to the language, the set of strings that match this pattern. Um, and notice that regular expressions are not unique, right? The same regular expression can define the same language. For example, 0 plus 1 or 1 plus 0 both define the same language. It's the regular language that have two strings in it. One of them is 0, one of them is 1. Okay. And of course, deciding given two regular expressions whether they're equivalent or not, namely whether they are defining the same language, right? The set of words that the match is the same, is an important task. We will see later on in the course how to do that. It's not going to be easy. It would require several steps. Uh, through some other representation of regular languages. Um, and in any case, um, conceptually, two regular expressions are equal if they represent the same language, right? But okay, now to keep things easy to read, we're going to omit parentheses pretty aggressively. So the idea of using all this notation is that we are going to write regular expression the same way that we write arithmetic expressions, right? So multiplication is going to be concatenation, plus is going to be OR, power is going to be, the same as concatenation repeated the specified number of times. So as such, we can omit parentheses using the same priority as in arithmetic operators, right? So raising to the power has higher priority than concatenation, which is multiplication, which has a higher priority than union, which is denoted by plus. Okay, and of course, a lot of those operators are associative, like concatenation, right? When you concatenate three string R, S, and T, it doesn't matter whether you concatenate first the last two and then with the first one, or the other way around. So in this case, if you have two or more, you can just omit the parentheses. Same goes to the plus, right? The union operator, the ordering doesn't matter. We're going to use the superscript plus. If you want, this is the Clini plus. This would correspond to applying the Clini star, but at least once, right? So formally, the R plus is defined as R concatenated with R star, right? And you can think about the difference between the language R star and the language R plus. And we will get back to that in the exercise, probably. Okay, now there are going to be a lot of equivalent ways to write the same thing, right? So the union operator, we either use R plus S or R or S or R vertical line S, all three ways of writing logical or union. Similarly, when we write down the concatenation operator, we will not bother to write down this dot to say that we are concatenating the first string with the second string. As in arithmetic operators, if there is something missing there, then it's concatenation. While in regular expression, if there are two things one to the next other, there is a multiplication, of course. Okay, we would like to be able to, given a language described in human language, we would like to be able to convert it into a regular expression, if there is a way to convert a regular expression. And of course, we would like to also do the other way around, right? Given a regular expression, we would like to be able to to describe in English what the regular expression here. And here it's very important when I said describe it in English, I don't mean to just read out loud or write explicitly with the regular expression. I mean to really, give a logical description of the underlying language. And both tasks are non-trivial, but hopefully you would be able to do them later on. Okay, this is it for now. Thank you.